Hello everybody and welcome back to the Moshix mainframe channel. This is Moshix and today we're going to be looking at ways to run Linux on the mainframe. And the reason that I'm looking into this today is that I've had several people write to me in the comments of previous videos or sometimes by direct email asking me to show them how to get Linux to install on the mainframe, and of course we emulate the mainframe with Hercules. Now before we go and see how to get this done, I would actually first discuss what are the merits of using Linux on a mainframe, because I just need to say straight up front at the beginning of this video that there's nothing special at all about Linux on the mainframe. It's just Linux on a mainframe, and as such you get all the usual things that you do with Linux. You have the command line. We do not have a desktop environment because we don't run this on the mainframe. You can obviously still run a user interface through the X11 system, so you would have, if you have a Linux on the client device, you can still display the apps that you would run on the mainframe. You can get anything to run, but mainframe is obviously a server environment, and on the server we don't need to run a desktop environment. So it's probably strictly server Linux, which means command line, which is fine for everything. But so the question is then, why do we need to run Linux on the mainframe? And I think the answer relies in IBM's RAS capability. If you search for IBM and RAS, you will see that IBM for the last, well, ever since the inception of the 360 series in 1964, they've been promoting something called RAS, which means reliability, availability, and serviceability. What this means is that the mainframe was built, and I'm talking about the real iron mainframe, is built for reliability, and we all know that. It is the most reliable server environment out there, far outperforming anything you would have from the x86 servers, or even from the Oracle Sun microsystem servers, or HP based servers. It is simply the most reliable environment, and a big part of that is because they use premium components, whereas in the x86 server world, obviously it's all about being competitive with pricing, so they go for cheaper and cheaper components all the time. On the mainframe, they use the best components out there. Also, there's a lot of redundancy built in, as well as the software plays very nice with the hardware, knows what state the hardware is in, and can adapt accordingly. And then finally, the engineering of the mainframe is just the gold standard. Then you have the availability, which plays to what I said before. The software plays very nicely with the hardware. The mainframe operating systems such as ZOS, ZVM, ZVSC are built to run only on IBM's hardware. And so, and that's because the hardware talks to the operating system, and that increases the availability. And the software can fail over much better. There's also in the software, in the operating systems of the mainframe, such as ZOS, there's a lot of error catching. For instance, ZOS, we have an environmental recorder which records every single error that happens, and in production shops, those logs are being inspected on a daily basis. It's just and that increases availability. And then the serviceability, which IBM invented the hot swapping of certain components on the server. It invented being able, the easy access to components that need to be hot swappable, etc., etc. So if you put reliability, availability, and serviceability together, you just get a great environment for running mission critical applications for the business or for government or whatever, in non-stop, and that is just unparalleled in the in any other server environment out there. And so whether you have your applications running, Linux-based applications running on an x86 server or mainframe, it really doesn't matter. It's just recompile, and then you get the advantage of IBM's RAS, and so that is one huge advantage, and that's why some shops run Linux on those machines. The second one is that the processors on the Z architecture are faster than anything you get currently in x86. Those processors are running at 5 gigahertz, 5.5 gigahertz. I think they're going towards 6 gigahertz. So you get a higher instruction execution speed on those processors as well. Obviously, the Linux was never really meant to run on the mainframe environment, so some things are strange to Linux when it runs on the mainframe. Channel adapters, all that kind of all those concepts are a little foreign to Linux, but it's been made to work. And in fact, about 20 years ago, I contributed to some of the bin utils, the binary utils for Linux. I think that was about in 1998. I wrote some of the binary tools for Linux, and then IBM took it and then brought it, of course, much farther. And so today it's a growing market share for IBM running Linux on the mainframe, and in fact I think it's probably the only growing market for IBM mainframes out there, and there are environments where it does make sense to run Linux on the mainframe. And the other thing is that you have LPARs on the mainframe, so you can run hundreds of copies of Linux on top of the LPARs, or what probably most shops do, they run ZVM, the virtualization system of IBM, and then run hundreds or thousands of images of Linux on top of that, which is great probably for service providers. Anyway, so that's the reasons to run Linux. But once you're inside Linux on the mainframe, there's really no difference at all. Today, however, I'm going to show you first how to obtain a working Linux image from me, and how to set it up and run. Now, one of the things is that there are some websites out there, such as this gentleman here, Steve Debian Stuff. He got Debian to run on top of Hercules, and that's how I got my Debian image to run on Hercules. I followed his instructions. However, the big problem is if you follow his instructions today, it just doesn't work. And the problem is that the Debian mirrors out there on the internet don't have the old version that this is referring to working anymore, and so you go through about to this stage here if you follow this website, and then it just doesn't work anymore. And then there's also another gentleman who also has a website. Let's see if this is the person. Nope. Well, there was one more website. Both of them just don't work anymore. So it's a lot of work to get it run. You have to follow every little line precisely, and then it gets stuck anyway. So I thought what I'll do is I just make an image of Debian on the mainframe available for download. Obviously, download it at your own risk. You're running a piece of software that will be, that is going to be connecting to your network. So obviously I didn't put anything in it, and you would have to trust me on that, but always be careful when you download software and running on your network, because Linux, as we'll show, will be able to reach out your network. Just make sure that you go in and check and clean the environment that you have. It is clean because I did it, but you should always own the software that you run yourself. So let's get started. So in the description below this video, I'll make a link available where you can download the ready-made images of zLinux. You just download it, and once you download it, you'll be presented with a directory such as this one, this is exactly how it will look. And if you follow me here on the screen, and so let's see how to get this running. First of all, let's see what the configuration file is for Hercules. I'm giving it here 4 gigabytes of memory, which kind of needs to have acceptable performance. I'm giving it 4 CPUs, and this is running on an i7, so it's a very fast CPU, and then it runs acceptably fast. Obviously, this is about 100 times slower than it would be on a real iron mainframe, and I hope, obviously you would have to be aware of this, that this is not running at normal speed. And then the most important part is where I use the channel-to-channel adapter to give this a network connectivity. And so the IP inside Linux on the mainframe is going to be 10.1.1.2, and the IP on the for Hercules on the real box is going to be 10.1.1.1. And so we just have to establish then links and gateways between these two addresses, and everything should be nice and dandy. So this looks snug here. We have obviously a console, we have a terminal, we have a reader, which is needed for the installation. We have a printer, and then we have 2 DASDs. The third DASD I'm not really providing here. You could just add, you could create a 3390 and add it there, and then you would have more space. I didn't want to make this download too big here. We have a tape device, and as I said, the network. So once we got this done, the way to get this running is pretty simple. I use my Hercules is the Hercules that comes when you do apt install Hercules. If you do this, then I will get this Hercules installed that I have here, which is Hercules 3. This would be Hercules. Where is it? Where's the? You see the version number here? I don't see it, but we'll see it when we get it up and running. So to get this up and running, we just do Hercules minus FZ Debian version. Okay, here it is, version 3.1.2, which is the current one available from the Debian mirrors. And I'm just running this on top of Linux. I mean, you could also run it on top of Windows. There's really no difference. And then to get it up and running, we would IPL from your device 120.0.120, which is E. So I press L for IPL and then E. And Linux will start to come up. ZIPL, you can see that ZIPL is obviously not Linux language, so that's why you can see here from that this is on the mainframe, and it's starting to boot. Let's see the speed. I'm getting about 80 MIPS right now, but it should go up to much faster. Yeah, get 400 IOs per second, 150 MIPS, 170 MIPS. I've seen this go up to, on this machine, to about 370 MIPS, and this is running inside the virtual machine. So I think an i7 should be able to pump about 400 MIPS or about 100 MIPS per processor, because I have 4 CPUs here, as you can see. So that's it. Linux has started on the mainframe, and now how do we connect to it? Well, with SSH, you do root at .1. First, before we do that, we have to establish connectivity. So okay, what we need to do is we need to run this this script here, which configures the network connectivity for the virtual machine, for zLinux on Hercules. Let's look what's inside. So we'll look at it with Okay, so this is a couple of rules to the Linux, and that when I'm saying Linux, this is the Linux on the hardware, on the real Linux, not the one running on top of Hercules. And so first we delete all firewall rules. So if this is exposed to your outer perimeter, be aware that that I'm resetting here the firewall. And then I just echo 1 into the IP forwarding proc interface, and I'm echoing 1 into proxy ARP of the proc interface. And this is required so the ARP will work, which is the Ethernet addressing protocol to be able to access everything. So we run this script by doing shell set network. Okay, we execute it, and now we have the network set correctly. And now we can just do connect to the Linux running. I'm just switching screen here. As you can see, we're now connecting to this Linux here. We can see this is just waiting, not doing anything right now. Go in, and the password is moshix. Okay. And you greet it with this. So I have, once you're inside, if I want to ping Yahoo here, you'll see this is not going to work. What we have to do is route at default gateway 10.1.1.1. And now if I try, now we have network connectivity through. And then in my case here, what this means is that Linux here on top of Hercules is now connecting to the Linux underneath Hercules. From there it's connecting, because this is running into the virtual machine, through the bridge network out to the real Ethernet interface of the real hardware. From there it's going to my router, and from my router it's going to the firewall. From the firewall then finally it's going out into the wild open internet. So this works just fine. And now let's see how this Linux, how you get to feel that it's actually Linux running on the mainframe. Well, for one, if I do uname -a, you see that this is Linux S390. And so this is the 390 architecture. And this was compiled, this kernel, last year. This is when I installed this image. And we, as far as I know, we even have Apache running here somewhere. So you can make this a web server. One more useful use for Linux on the mainframe, in my view, is as a perimeter machine. What I mean is that since this is a different architecture, the processor architecture, all the scripts that script kiddies run to attack machines out on the internet, most of them will not work, probably 90-95%, because these are not x86 machines, and so when they try to inject x86 machine instructions through those scripts, they will just simply fail on top of Hercules. So that's why I have a machine out there in the internet, which is my SSH access machine, and to make it a bit safer than just having an x86 machine exposed out there, I have Hercules being exposed, so that I have this extra layer of security. That's one useful need of Hercules-based Linux for the mainframe. So we can see it also from there. Then I have in the root directory, you'll see I have this subdirectory called C code. And the reason I did this is I wrote a very simple test program. Nothing special here. And then I compile it. GCC is, by the way, installed. Oops. GCC 4.9.2, very recent GCC compiler, C compiler. And the reason I have the subdirectory here is to show that this is mainframe. So I do GCC -s test.c. And the end result will be this new file. When you tell GCC -s with a capital S, it means also produce the assembler output before assembling it. So this is what this produces. Let's look at it. And you will see immediately that you know, for those of you who know S360 assembler or the mainframe assembler, you will see that these are all mainframe instructions. Now, one difference is though that this is the GNU style assembler notation, which is different than the assembler we use on the mainframe, typically within MBS or ZOS. But these are instructions for the mainframe. Long. All this L means these are 64-bit instructions because their L means long, or could also be 31-bit instructions. But this one, for instance, is 64-bit. And here we have our little program here written in mainframe assembler. This would not assemble on an x86 machine. Assembler test.s, and if you can see, this works. So and then we can just that's strange. Yeah, no, I don't know what happened there, but yes, this runs perfectly. So, and then I can show you here that we have two volumes. This is device 120 and this is device 121. You have 2 gigabytes each. You have your home directories here. Everything else is just standard Linux. I mean, there's really not much more I can say here because this is not a Linux tutorial. I will assume that you know how to use Linux. You can do your usual apt update. So you can see this is actually quite fast. This is probably running faster than Linux on a Raspberry, which I use quite a bit, but this is slightly faster, I think, than a Raspberry machine. So I would say not bad at all. And this is it's running right now. But let me stop it. But you could also do screen -A. All those commands work. Obviously, I'm already inside the screen session, so I would have to change the key bindings. But this is all just normal stuff. Everything works as normal. We have SSH. I can SSH out from here somewhere, or I can telnet to my OpenVMS. How about that? Telnet. This is fun. So I'm running now Linux on top of Hercules, on top of Linux, on top of VMware, on top of real hardware, and from there I'm connecting to my other machine, which is running OpenVMS, an OpenVMS cluster, and I will also have a link here to my previous video on OpenVMS clustering, on top of the SimH emulator, on top of Linux, on top of another box. So just for fun. This is the cool stuff you can do with a very small lab here. In my home here I have 6 or 7 Intel NUCs. Let me show you again what Intel NUCs are. So I'm running this on top of a tiny little machine like this. These are about 3.5 inch wide and about 2 inch high. Very small, you can take them anywhere. So I have about 5 or 6 of those, and this is all running on top of machines like this. I mean, this is, and it takes maybe a tiny little corner of my desk here. Maybe I'll post a picture of my working environment here, and you can see here I have my OpenVMS cluster with 1, 2, 3, 4, 5, 6 machines in the cluster, all perfectly running. I have here installed, oops, yeah, I have edit swinoid.bas. I have a little program here that prints a sine curve on the screen. So again, Cyanoid, open VMS rules, and log out again, back again to my Linux on the mainframe, and I think we'll close here. Download this image, put it on your system, and give it a spin. And for any questions, post comments below this video. If you like this video, please press on the thumbs up button. It always motivates me to do more of these videos. And please do subscribe to the moshi mainframe channel to get notifications of future videos. Thank you very much, and goodbye.